screen is what you had for your homework, and we're going to go through that for trusses. So this is the chapter 4, and the schedule right now looks like we'll talk about chapter 4 today. Next week we'll talk about 5. And once we get through chapter 6, we'll have an exam on that. Originally it was supposed to be October 8th. I don't know if it will be then or not, but we're about a week behind, and we're a third of the way through the semester. I really can't slow down, or you won't get the information you need to move on. So y'all need to catch up, is my point. So, are most of y'all got through the chapter 3 stuff, and you're into this now, right? And you're on board and you understand. Okay, so let's see. This first page, I don't need to read through it all. I assume you already did all that. First place where that asks you for a answer. Not there. Okay, down at the bottom. Okay, here. That is where it says now solve for H3 and H7, I believe. Let me find that on mine. Did y'all work through all these? Or are you still doing it?
I got through most of it, and Bob got through most of it, but we didn't finish. We stayed on page 7.
Okay.
Page 6. But I didn't understand why that 2 to 8 force is 0. It's just because the bottom force, there's no force pushing back against it?
Yes.
Even though that there's a 400 pounds pushing on the top?
But that's going...
That displaces to the other ones, and that one stays 0? Okay.
So the question was, for my microphone purposes, why, if you're looking at this force here, why is it 0? It's because this 400 pounds goes that way, and there's nothing pushing up on here, so there is no force. Everybody understand that? And you understand how basically this truss problem is just a bunch of little bitty free body diagrams, right? You just got to divide it up and work it out individually. So did anybody find out solve for H3 and H4 that wants to share?
H3, I got, because from your formulas you have H3 is equal to 8 over 6 times 250, which is your,
It's 8 over 6 times V3, yeah.
So if you reduce, so then you end up with, I ended up with 1,000 over 3, which divides into 333 pounds.
That's right. Everybody agree with that?
Yeah.
Yes. So H3, your answer down here is going to be H3 equals 8 over 6 times V3. V3 from earlier computations is 250. So that's going to equal to 333 pounds. Do you want me to write that on here somehow? Let me see. It takes me so long to do this. See if I can figure it out. So H3 equals 8 over 6 times V3, right? Then H3 equals 8/6 times 250, which we got that from above, which then equals 333 pounds. So then what's H7 going to be if you use the same technology? If H3 is 8/6 times V3, H7 would be what?
8/6 times V7.
Right, so that'd be 8/6 times V7. And then substituting out, H7 equals 8/6 times V7 from earlier we saw was 200, right? And that equals 267 pounds. All the answers are positive in this situation, therefore segment 2-3 and 2-7 are in compression. Do you understand compression? Somebody had a question about that online. 2-7, when the two forces right here are pointing toward each other, like 7's going up and from 2 it's going down, that is compression. If they were pulling away, it'd be tension, and usually that's indicated by a negative. Sometimes, not always, it might be different. Also, in general, top chords of trusses, if you go back to this page, top chords are in compression, bottom are in tension, and that's because the bottom will tend to bend, and that's pulling action, so that's going to be in tension. The top is pushing down, so that's a pushing action. That's like compression. Okay? Back to what page was that other one on?
What did you put for H7? 267?
Yes.
Okay.
Forget what page it was on. There it is.
It was on page 4.
Okay. So then, if we move on to the next page, up here, I don't know how I get rid of this stuff, or how I make this smaller. Anyway, if you can read through that, it says, solve for the chord 2-3 and 2-7 using the Pythagorean theorem, a squared plus b squared equals c squared. So what they're saying, going back to here, you want to solve for 2-3 and 2-7, because those are both going to be the hypotenuse of the triangle, right? So you can do a squared plus b squared equals c squared. So you have, you know what all those other components are. So did everybody get that?
416.
2-3 is 416. Is that what you said? And 2-7?
Is 334.
333 or 334?
34.
I got 333, so let's figure out why we're different.
Probably with the rounding error.
Probably.
My calculator always forgets a 0. 200, not that. 333.6. So when you round up, 334.
Okay, I'll go with either one. So 2-3 equals, I'm not going to write out the formula because I can't do that on here. 416, and then chord 2-7 equals 333 or 4.
3.
Okay, 333. So, and you got that by doing a squared plus b squared equals c squared, which would be 2-3 is 250 squared plus 333 squared. The square root of that is going to be 416, and for 27 it was 200 squared plus 267 squared, square root of that being 333. Okay? So now you need to, it says to move on to joint B, or 3, I'm sorry, looks like a B. And they've drawn it out for you here. So the first question is the sum of the horizontal forces must be equal to 0, so H3, which equals H3 minus H4, H3 going in the positive, H4 going in the negative. So then if you put H4 back over on the other side, you get H4 equals 333. That's right. I'm going to write that in there. Whoop, I did it. Okay. So, and because then by geometry, it tells you that V4 is going to equal 6 over 8 times H4 because of our 6 to 8 ratio. So then, if you know right, okay, we already have H4. I'm getting lost here. Hold on. So did somebody figure out the answer to V4?
V4 is equal to 6 over 8 times 333.
That's correct.
So when you, it comes out to 250 pounds.
Okay, let me write that in there. Because we know that H4 is 333. So then you can do the sum of the verticals, V7, which is that one, plus 200 down, which is above it right there, equals V3 going up plus V4. So then V7 is going to equal,
300 pounds.
right. Okay, so member 3-7 equals 300 pounds.
I put that it was in compression.
I think it's intention. Let me see. V7. Remember. Okay, remember 3-7. Hold on.
The way I think of it as it's pushing it down, so it's compressing
Wouldn't
it.
that be the same as going from 2 to 8 with it being lower?
It's the same as what?
Wouldn't that be the same as the cord going from 2 to 8 where you said there was no load on it?
Well, no. V 3-7 has that. Well, let me see. 3-7.
But the difference between 2 to 8 and 3 to 7 is that 2 to 8 is 0. It has 0 force, and 3 to 7 has 300 pounds of force pushing down. So it's compressing it, no? Because it's
Yeah,
not pulling it, it's pushing it down.
that makes sense, but I'm not sure. Just seeing if I have a note about that. What?
The opposite, it's gonna vertically on the vertical.
Yeah, it's
Or
going
gonna
up,
be straight
there's
up
nothing
and down.
pushing up on it, so.
So it'll be in compression.
It'll be a compression.
Okay. So we'll say compression. I'll circle that. Okay. Now the force in the chord 3-4, which is this one right here, is going to be the Pythagorean theorem again. You're going to have H4 squared plus V4 squared square root of that is what?
416.
Hope y'all are all in agreement with this. Not just copying. Because you'll get lost later if you don't understand it. So you need to speak now or forever hold your peace. So that's 416. And it's in compression. That's correct. So we'll circle that. Okay.
Wait,
What?
earlier you said that if they're pushing on each other, if you have two forces pushing on each other, that's in compression, right?
Generally, yeah.
And if they're pulling away from each other,
It's tension.
so if 3-7 is pushing down and you have nothing pushing back,
Maybe that, yeah. So it's pulling away from that joint.
but you have nothing pushing back on it or pulling on it,
So, but it's elongating, so it's in tension, right? You see what I'm saying?
see, because I'm thinking that 200 pounds is pushing it down,
There's nothing pushing up on it.
and then the other 2 pounds, the other two pressures on the sides at 2 and 4 are also pushing down on that, helping push down on that. I think it is compression.
You mean tension or compression?
Compression.
Well, that's what we said, isn't it?
Yeah, I was thinking that because maybe that it might be tension, but
Well, we're talking about this one right here.
yeah.
So,
If those three forces are pushing down,
but if you know, this bottom one is going to tend to bend. That's why it's in tension. It's sagging with the load. This one is just hanging there, and there's nothing pushing up on it.
you know what? I think it is tension
I think so too. Now that
because I'm sorry. I'm very
That's okay.
visual.
do you want the little
If
thingy?
you isolate it.
Where's my little? You want this?
Let's see if I can do this. If we isolate and we mark this one and this one are pushing down this way, right?
Mm-hmm.
And this one is pushing down also this way, then this is going to be stretching, like you said.
Yeah.
So it's going to be in tension.
Okay, so we'll change that.
So then we can erase that what I just drew in.
Okay, now that was back on page 4. So 3. This is going to be in. It won't let me erase it. Let's see.
Undo.
Well, that's too far back. I don't want to
Oh,
do it. Why won't it let me erase that?
Don't you have to click the eraser?
I did.
Is that an eraser?
I think so. Well, let me do this.
I'm trying to touch my screen.
This is it.
That's how my answer sheet looks.
Okay. All right. So now we're on the next page. No. Are we on that page? Where are we at?
An opposite to joint 7.
Okay, and it gives you a picture. And then the next page. I wish I could get rid of this thing. Okay, it says the sum of the horizontal forces cannot be used yet as there are too many unknowns for joint 7. So the sum of the vertical forces equals 0. 300 plus 300 plus V4 equals 200. So therefore V4 equals minus 100. Oops, it says V4 must be downward. Go back up here. Yeah, so that one must come down. So then, by geometry, H4 equals 8 over 6 times V4. H4 equals 8 over 6 times 100 equals 133 to the left because V4 should be downward. Sum of the horizontal forces then can be 600 plus H4 equals 267 plus H6. Notice that H4 should have been drawn to the left as seen from the computations. Then it goes on to tell you 600 plus 133 equals 267 plus H6. H6 equals 466 to the right. Force 76 is 466 in tension. So this force is in tension because, yeah. Wait, force 466 in tension. Force 7.4 is the square root of 100 squared plus 133 squared equals 166 squared. Compression, sketches an arrow. Okay, so then when you get all that, joint 6 can be solved, and you can do the sum of the vertical forces of force 6.4, which is that one, equals, and the sum of the horizontal forces. So did y'all get 6.4? What is that going to be?
I had on the up here where you have 600 plus H4 is equal to 267 plus H6. That 267, that's H7. Is that where that comes from? Because the only pressure that we have on our sheet so far, that's 267.
Yes, it comes from H7, yes.
Okay, I was wondering where that came from.
Yes, you should be going back and, looking at the previous pages, which is hard to do on the screen. Because you're using the step that you got earlier. So, then the sum of force 6.4 is going to be equal to what? Going to be the same like as 2.8, same situation.
It's going to be 0.
Right. That's going to be equal to 0.
And then 6.5 would be equal to 6.7, so it would be 466.
Yes, 466. Because, yes, because it has to, the sum of the horizontals has to be equal 0, so it's going to go 466 the other way. Right? Everybody follow? Okay. So then the next page. Finally, it says joint 4 can be solved. Wait, I'm missing a page. 7. Oh. So, and it gives you a picture of joint 4. So the sum of the horizontals must be equal to 0. So we're looking at joint 4, and and the only horizontal we don't know is H5, right? So it's just going to be equal to what?
133 or 466.
Right, 133 plus 333 equals 466. So that's what that one equals. So then you got your sum of your verticals is going to be V5, this one right here, plus 100, this one over here, minus 250, or, wait, okay, well, let me start over. You got V5 plus 100 going up, then, and then you got 250 and a 200 going down. So you've got 450 minus 100 is going to be equal to V5, right? So that'll be 350. Did you follow me?
Yes.
Minus 100 equals 350. So we got 250 plus 200 is 400. Minus 100 is going to give us this force over here, which is going to be 350. So with that information, the force member in 4.5, this one right here, can be figured out using the Pythagorean theorem. So that's going to be the square root of H5 squared plus V5 squared. What is that?
582.8, so 583?
Yep, 583. Anybody got any questions? Speak now, forever hold your peace. Okay, so to check, then to do a double check, you can verify that joint 5, our last joint, is in equilibrium. You can substitute the values for V5, H5, and H65 to make sure everything equals 0. So here, you'd have the sum of the horizontal forces of, would be, what are our horizontal forces?
466.
And then minus 466, right? Equals 0. So that checks out. And then the sum of the vertical forces,
V5 is 350 minus 350.
right, that checks out too.
Is the solution? Yes.
Yes. 350 minus 350 equals 0. So is the solution correct? Yay! It is. And then,
The final value.
so in here you should fill in these blanks with all of these dilly bobs. So what's this one going to be? Right here.
Hold on, I have that. 2 to 3 is going to be 416.
And is it compression or tension?
Compression.
Oops, hold on. I don't know if I can write small enough for this part. Maybe I'll do it this way. 4, 16, and compression, if you can read that. Okay, and then what did you say? What's the next one?
27, which is the one that's coming down, is going to be 334 in compression also.
This one or that
Yeah.
one? This one?
That one right there.
Right. That's 333 in compression.
334.
Oh, you're right. So exact.
I want mine to be right.
Earlier you told me 333.
No, you said 333.
334 in compression. Learning to write with my mouth. Okay. So what's this one right here?
We said that was 300 pounds in tension.
Okay. You should write yours, if you can, alongside it. I can't do it that way. This is hard enough. Okay. And then what's this one over here? Three, 4.
Okay, look, I'll make it easier for you. Here's your little pen.
I can't write on there either.
No, why not?
It looks retarded when I write on there.
416. Okay, it doesn't want to make a little
See,
circle.
that's why I'm telling you.
Okay, you can undo it. I can, if it's undo.
Oh. See, it's not as easy as it looks, is it?
Right? 416. Right, is that what I have? 416 in compression.
Mhm.
And
And the
then you
last?
said this was, down here was what? 466?
That's 7.6. Anybody else following along? Okay. So is that 466?
6.5, 466.
6. Which one? No. 6, 7.
466.
Yes. In tension.
Intention.
Both of them are actually 466. And then the last one is 4.5.
4.5 was, well, I don't have that on my paper. Who has that? Anybody write that down? 4.5 was, should be somewhere here.
583.
583. And
Compression.
compression.
So we did it. Figured out a truss. You're awesome. Okay. Now, if they also talked a little bit about method of sections. And to me, when I read the chapter, I felt like it was Greek. Y'all probably thought it was Greek too, right? Were you reading Greek? Okay. So, go back, find that section. The method of sections is, it's kind of the same thing, but different. I mean, we use the same principles. Let me see if I can make a new page. Insert new page. Okay. So in your method of sections, you basically, and I'm going to try to draw here. You know, if you have a wall or something, and then you have your supports, and you have a truss coming out from that wall, like a something like that. It goes up and down. There's a support here. That goes up and down. Anyway, so we'll call this one F, this one E, this one B, this one C. Those are supposed to hit at the same point, and this one D. And then this dimension here is 4 feet. It's going to be 4 feet tall from there to there. And then each one of these is 4 feet. In between. And you have a 600-pound force at each one. Oh, this one's 800, sorry. Where'd that come from? This is 600. And 800. Okay, so when you do a method of sections, basically all you want to do is cut it in half. And for this one, we're just going to like chop it right here. And we're going to kind of get rid of all this stuff over here. Why doesn't it let me erase everything? I don't get that. I didn't save it. That's weird. So from that, then you can draw a new little diagram. Maybe that's easier to do. You're going to have your E, C, and all you care about is stuff over here. And you know you're going to have a force going that way. You have a force coming up there. And then a force coming this way. And what we want to do is figure out, let me see, so we cut it there. We're trying to figure out this right here. Maybe it's easier for me to draw it up there. figure this out is using sum of the moments about C. Must equal 0 from our forces of equilibrium. So then you know that EF, which F was that way, right? Erase something. Yeah, F was this one up here. So if you're looking at C, EF times 4, that's going to be a minus, a negative moment. So you got minus EF times 4 feet, that's what we're getting at. Then the other force is going to be 800, which is this one right here, because we're circling C. So 800 in the positive direction times 4, so that's going to be plus 800 times 4. So then you get minus EF equals 800 times 4 over 4, which of course cancels out, right? That cancels out. So so EF equals 800. So we know that that force is going to equal 800 right there. You follow that? So then we're going to do the sum of the moments about F. I think, yeah, sum of the moments about F. So force CB, do that one over here. Sum of the moments about F, which is over there. So we're trying to figure out this, in case you lost it, trying to figure out that force right there. So the sum of the moments about F, it has to equal 0. So the force, so CB times 4, which is going to be positive moment. So you got CB times 4, because it's 4 feet, plus, you got your 600 right here. 600 times 4, plus, I got one more, which is the 800, oops, wrong way, 800, and that's 8 feet away from F, 800 times 8. So you add all that up, you got CB plus 2400 plus 6400, CB4, sorry. So then that equals what? 800, 8800? Divided by 4, you're going to get 2200. Follow that? So CB is actually going to be equals minus 2200, because we had to switch sides to make it a negative. So then, back up here, it's in tension because it's pulling away, so that's going to be 2200 force of CF times the sine of 45. You want to do it the trigonometry way. So, write that out. You got minus 600 minus 800 plus whatever that force CF is times the sine of 45. So then you get 1400. That's going to be minus 1400, but if you flip it over here, it'll be 1400 equals CF sine 45. And then you can divide the sine of the 45 by that to get your CF. And that should equal 1980. So we figured out through the method of sections, which that this force here is 1980. By chopping it and then just focusing on that point and figuring out the components in it. Do you have any questions on that? It's just, I mean, you got to remember all of this, see how it all builds on everything. It's just a layering effect. So, how do y'all feel about that chapter? You feel confident? Wondering if I should, let's see here. I think I should give you a problem to work on, because I think you understand it when you work through it. Is that correct? So I'm looking to see what I want to give you. Do you want a method of joints problem, a section problem, or both? Using the algebraic method of joints, find the internal forces and truss. I think I want you to do, should have been more prepared about this part of it. I don't like the problems in the book. That's the trouble. If you look on page 69, problem 4.2, A comma B doesn't make sense to me. it says, using the algebraic method of joints, find the internal forces in the truss in figure 4.4. I guess that does make sense. Does that make sense to y'all to do that? So let's do problem 4.2a only, not B, just A. And then I'll write it on Canvas later too, but let's do 4.2a, and then let's do, and don't count, you can look in the back of the book to cheat, but, you know, don't count on it being right back there. So, and do 4.3a as well. But don't just do the method of sections, not the Maxwell diagram. I think that's confusing. So I want you to do 4.2a, method of joints, and then 4.3a, method of sections. Okay, and then we'll, for Tuesdays, I'd like you to submit that to me in a scan by Tuesday. And then my topic on the Tuesday discussion will be chapter 5. Some of it. Chapter 5 is pretty long. You're going to have to break that down. But, I'll get into chapter 5 on Tuesday. Make sense? Okay.
I'm okay, man. I'm gonna turn my stuff in later.
Oh, you got to show me that other